Hello everyone and welcome. I'm excited to kick off our presentation today. The topic we'll be exploring is fractions. On this first slide, you'll see the title Fractions along with a brief overview. Over the course of this presentation, we'll cover what fractions are, how to work with them, and why they are important in everyday life. I'm looking forward to guiding you through this journey, so let's get started. Let's take a quick look at what we'll be covering in this presentation. First, we'll start with the index to give you an overview of all the topics. We'll explore what fractions are and look at some simple examples to understand them better. Then, we'll discuss the different parts of fractions and delve into mixed fractions and how they relate to whole numbers. We'll also examine how to find equivalent fractions and perform operations like adding and subtracting fractions, including those with the same and different denominators. Understanding how to convert unlike fractions to like fractions is crucial here. Next, we'll explore multiplying and dividing fractions, including mixed fractions, and see how the numerator and denominator control the size and value of a fraction. We'll also look at comparison techniques to see which fractions are larger or smaller. Throughout, the focus is on building a solid understanding of fractions, what they are, why they matter, and how to work with them confidently. This foundation will help you grasp more advanced concepts later on. So let's get started. Let's take a look at the index to see how our presentation is structured. As you can see, we start with the basics. What are fractions? And then move through various types and operations involving fractions. We'll explore examples, compare like and unlike fractions, and understand how the numerator and denominator control the value of a fraction. We'll also look into proper and improper fractions, mixed fractions, and how to perform different operations such as addition, subtraction, multiplication, and division. Throughout this journey, we'll see how fractions help us understand parts of a whole and compare quantities effectively. This roadmap will guide us step by step to build a clear understanding of fractions and their significance in math. Now, let's explore what fractions are. Fractions are used for counting parts of something. Think of them as a way to express a portion of a whole. Loosely speaking, a fraction is a quantity that can't be fully described by a whole number alone. The word fraction comes from the Latin word fractus, which means broken, and that gives us a hint about what fractions represent, something that's divided or broken into parts. A fraction is essentially a number that can show us how much of a whole we have. The earliest fractions were quite simple. They were reciprocals of integers. This means they represented one part out of 2, 3, 4, and so on. These were often symbols used in ancient times to show parts of a whole. Later on, a more familiar type of fractions developed, what we call common or vulgar fractions. These are the fractions we still use today, like 1/2, 5/8, 3/4, and so forth. These fractions help us describe parts of a whole in a clear and standardized way, which is essential for understanding ratios, proportions, and many other concepts in math. So, in the context of our overall theme, understanding fractions is fundamental because they help us measure, compare, and understand parts of a complete object or quantity. Now, let's take a look at some practical examples of different types of numbers and fractions. Here, we have a variety of formats. For instance, we see simple fractions like 1/8 and 1/12, which are common in measurements or dividing things into parts. Then, there are mixed numbers like 1/2, which combine a whole number with a fraction, making it easier to understand quantities that are more than a whole but less than 2. We also have larger numbers with fractions, such as 55/60, which can be simplified or interpreted as a ratio or a percentage. Notice the number 1/210. That's a mixed number where the decimal part can also be expressed as a fraction, emphasizing the versatility of how we represent numbers. Moving on, there's 1/210, which again combines a whole number with a fractional part, making it very clear and intuitive. Then, we see 11/12, a fraction close to 1, often used in contexts where precision matters, like probabilities or ratios. Finally, there's 1/210 again, reinforcing how fractional and mixed number formats are interconnected. These examples highlight the diversity of ways we can express quantities, which is fundamental to understanding measurements, ratios, and proportions in various real-world scenarios. As we progress, keep in mind how these formats relate to the overall theme of accurate measurement and clear communication of quantities. So let's think about the need for fractions. Imagine you have a whole cake in front of you. Can you finish the entire cake? Probably not all at once, right? Now, if you didn't finish it, how many cakes did you eat? Well, it's not just 1 or 0 because those answers don't quite fit the situation. This is where the idea of fractions comes in. Fractions help us describe parts of a whole, like eating half a cake or a quarter of it. They give us a new way to understand and express quantities that are less than a whole. This need for a new kind of number is exactly why fractions are so important in mathematics and in everyday life. They help us measure, compare, and make sense of parts of a whole in a clear and precise way. All right, let's talk about the parts of fractions. The denominator is the number that tells us into how many equal pieces the whole is divided. It's important to remember that this number can never be 0, because dividing something into 0 parts just doesn't make sense. The numerator, on the other hand, shows us how many of those pieces we're actually considering or talking about. Think of it this way: I am the numerator. I tell you the number of parts you're focusing on, and I am the denominator. I tell you the name of the part or how those parts are being divided. So, in a fraction, the denominator is all about the size of the pieces, and the numerator is about how many of those pieces we're referring to. Both are essential for understanding what the fraction actually represents. Let's look at this example to really understand how fractions work. Imagine we have a pizza here. The blue circle represents our whole pizza. Now, if we divide this pizza into 8 equal slices, what does that tell us? The number of slices the pizza is divided into becomes the denominator, which is 8 in this case. Now, if we look closely, we see that we have 7 of these slices. That means the numerator, the top number of the fraction, is 7. So we can say that we have 7 out of the 8 slices, or 7/8 of the pizza. This example helps us see how fractions describe parts of a whole. The whole is divided into equal parts, and the fraction shows how many parts we are considering. It's a simple but powerful way to understand portions and sharing, which ties into the overall theme of understanding parts of a whole in math. Now, let's take a look at the different types of fractions. First, we have proper fractions, which are fractions where the numerator is less than the denominator. These are common and easy to understand. Next, there are unlike fractions, which have different denominators, and this is where finding common denominators becomes important. Moving on, unit fractions are fractions where the numerator is 1, like 1/2 or 1/3. These are very fundamental in understanding fractions. Then, we have improper fractions, where the numerator is greater than or equal to the denominator, and they often represent quantities greater than 1. Equivalent fractions are different fractions that represent the same value, which is key when comparing fractions. Whole fractions are simply whole numbers expressed as fractions, like 3/1, showing the whole as a fraction. Like fractions share the same denominator, making them easier to compare or add. Lastly, there are mixed fractions, which combine a whole number and a proper fraction, like 2 and 1/2. Recognizing these different types helps us understand fractions better and see how they relate to real-world situations. Let's talk about proper and improper fractions. Proper fractions are those where the numerator, which is the top number, is less than the denominator, the bottom number. For example, 1, 2, 3, 4, or 2, 7. These fractions represent parts of a whole that are less than 1. On the other hand, improper fractions are when the numerator is greater than or equal to the denominator. For example, 4/2, 9/5, or even 6/6. Interestingly, every whole number can be written as an improper fraction, like 24, which is the same as 24/1. Understanding the difference helps us see whether a fraction is less than 1 or equal to or greater than 1. This concept is key as we learn to compare, simplify, and convert fractions in different ways throughout this course. Let's talk about mixed fractions. A mixed fraction combines a whole number with a proper fraction. For example, you might see 2/14 or 16/25. These are just different ways to represent the same amount. In fact, Mixed fractions and improper fractions are essentially the same thing. They can be converted back and forth depending on what's more convenient. Now, how do we convert an improper fraction to a mixed fraction? Well, you divide the numerator by the denominator. The quotient becomes the whole number part, and the remainder becomes the new numerator. The denominator stays the same. And if you want to go the other way, convert a mixed fraction into an improper fraction. You multiply the whole number by the denominator, then add the numerator. The result becomes the new numerator, with the original denominator remaining unchanged. Understanding these conversions helps us see that mixed and improper fractions are just two different ways of showing the same quantity, which is useful in different contexts. It's all about flexibility and clarity in how we present fractions. Today, let's explore the difference between like and unlike fractions. When we talk about like fractions, the key point is that their denominators are the same. This makes comparing and adding or subtracting them much simpler. On the other hand, unlike fractions have different denominators, which means we need to do a bit more work to work with them effectively. Understanding this distinction is crucial because it helps us choose the right method for simplifying or combining fractions. Recognizing whether fractions are like or unlike allows us to approach problems more efficiently and connects directly to our overall goal of mastering fraction operations with confidence. Now let's take a closer look at unit fractions and whole fractions. In unit fractions, the numerator, which is the top number, is always 1. This means we're talking about one part of a whole that's been divided into equal pieces. For example, 1/2 or 1/3. These fractions are fundamental because they represent single parts of a division. On the other hand, in whole fractions, the denominator, which is the bottom number, is 1. This indicates that the entire quantity is considered as one whole, so the fraction essentially equals the whole number itself. For instance, 3/1, which simply equals 3. Understanding these distinctions is important because they help us see how fractions can represent parts of a whole or entire quantities. Connecting this to the overall theme, recognizing these differences allows us to better interpret and work with fractions in various mathematical contexts. All right, now let's move on to converting unlike fractions to like fractions. The first step here is to simplify all the fractions as much as possible. This makes the calculations easier and clearer. Next, we find the least common multiple, or LCM, of all the denominators involved. This LCM will serve as the common denominator for all the fractions. Finally, we multiply each of the fractions by a special form of one that adjusts their denominators to this LCM, which results in all the fractions having the same denominator. When we do this, you'll see that they become like fractions, making it much easier to compare or add them together. This process is really important because working with like fractions simplifies the entire operation and helps us focus on the numerators, which are the key parts of the fractions. Let's talk about equivalent fractions. These are fractions that might look different but actually represent the same part of a whole. For example, imagine a cake divided into 2 equal pieces. If I take just one of those pieces, that's 1/2. Now, if we cut that same cake into smaller equal pieces, say 4 pieces, 2 of those smaller pieces still make up the same amount of cake. So 1/2 is the same as 2/4. And if we cut the cake into even more pieces, like 8, 4 of those smaller parts are still equal to 1/2. This shows us that 1/2, 2, 4, 4, 8, and even 3, 6 are all equivalent fractions, just different ways of showing the same quantity. Recognizing these equivalent fractions is important because it helps us understand that fractions can look different but still mean the same thing, which is a key idea in mastering fractions overall. Now, let's talk about making equivalent fractions. To do this, we multiply the fraction by a special form of 1. Remember, multiplying by 1 doesn't change the value of the fraction, but it helps us create an equivalent one. This special form of 1 has the same numerator and denominator, like 4/4, 10/10, and so on. For example, if we take 4/5 and multiply both the numerator and denominator by 5, we get 20/25. This new fraction is equivalent to the original because we've just scaled it up equally. This process is a key part of understanding how different fractions can represent the same value, which ties into our overall goal of mastering fraction equivalence. Now, let's take a closer look at the operations of fractions. When we talk about addition, subtraction, multiplication, and division, each operation has its own rules and methods. For example, adding and subtracting fractions typically require a common denominator, which means we need to make the denominators the same before combining the numerators. Multiplication, on the other hand, is more straightforward. Simply multiply the numerators and the denominators. Division involves flipping the second fraction and multiplying. These operations are fundamental because they help us work with parts of a whole in different ways, and understanding them is key to mastering fraction concepts overall. So, as we progress, keep in mind how these operations connect to real-world problems and our goal of building a solid mathematical foundation. Now, let's talk about the key points when adding fractions. First, simplifying is very important. Always look to reduce fractions to their simplest form before proceeding. Next, we need to understand the difference between like and unlike fractions. Like fractions have the same denominator, and that's a must if you want to add them directly. If the fractions are unlike, meaning their denominators are different, we need to convert them to like fractions first. This step is crucial because we can only add fractions with the same denominator. Also, remember that when adding fractions, we do not add the denominators, only the numerators are added. Lastly, if you come across an improper fraction, where the numerator is larger than the denominator, always convert it into a mixed number. This makes the answer clearer and easier to interpret. Connecting all these points helps us master the process of adding fractions accurately and efficiently. When we talk about adding fractions, the key idea is similar to combining objects in sets. Imagine you have two groups, say bundles or sticks, and you want to put them together. The important part is that these objects must be of the same type. So if you're combining bundles, they should all be bundles, and if you're working with sticks, they should all be sticks. Now, when it comes to fractions, this idea translates into only combining pieces that are the same size. This means the denominators, those bottom numbers, must be the same. If the denominators are different, it's like trying to combine apples and oranges. It just doesn't work unless they match. So the most important takeaway here is that, for adding fractions, the pieces need to be of the same size, which is indicated by having identical denominators. This concept helps us keep everything consistent and makes adding fractions straightforward, just like combining similar objects in our everyday lives. Now, let's talk about adding fractions that have the same denominators. The key idea here is quite simple. You add the numerators together, but you keep the denominator the same. For example, if you have two fractions like 3/6 and 2/6, you just add the 3 and the 2 to get 5, and the denominator stays 6. This makes the process straightforward because the denominator, which shows how many equal parts the whole is divided into, remains unchanged. It's an important concept because it allows us to combine fractions quickly and accurately when they share the same denominator. Remember, the main step is to focus on adding the top numbers, the numerators, and leave the bottom number, the denominator, alone. This idea ties into our overall goal of understanding how to work efficiently with fractions in different situations. When we're adding fractions with different denominators, the first step is to change them into like fractions. This means finding a common denominator so that the fractions have the same bottom number. Once the denominators are the same, we can simply add the numerators. Remember, changing to like fractions might involve multiplying the numerator and denominator of each fraction by the same number. This step is essential because it aligns the fractions, making addition straightforward. Connecting this to the overall theme, mastering this process helps us work with more complex fractions and builds a strong foundation for understanding fractions in general. It's all about making the parts compatible so we can combine them accurately. Now, let's talk about adding mixed fractions. The first step is to change the mixed fractions into improper fractions. This makes the addition process smoother because we're working with the same type of fractions. Next, we convert these improper fractions into like fractions, meaning they all have the same denominator. This step is crucial because adding fractions with different denominators isn't straightforward. Once we have our like fractions, we can simply add the numerators together while keeping the denominator the same. After adding, don't forget to convert the improper fraction back into a mixed number. That's the final step. This process highlights the importance of multiple conversions to make addition easier and more organized. Remember, understanding each step helps us handle more complex fractions confidently, which is key to mastering fraction operations overall. Let's talk about subtraction of fractions. When we're working with fractions, it's important to remember a few key points to make the process smooth. First, simplifying is always a good idea before you start subtracting. It makes the calculations easier and cleaner. Next, we need to understand the difference between like and unlike fractions. Like fractions have the same denominator, and unlike fractions have different denominators. For subtraction, like fractions are a must, so if your fractions are unlike, you'll need to convert them to like fractions first. That means finding a common denominator. Another important point is that the denominator should never be subtracted. Only the numerators are subtracted, while the denominator stays the same once the fractions are converted to like fractions. Also, if you're working with improper fractions, it's often helpful to convert them into mixed fractions for easier understanding and calculation. Keep in mind that the numerator can be negative, which is useful when dealing with subtraction involving negative values. So, in summary, always simplify, convert unlike fractions to like fractions, don't subtract the denominators, and change improper fractions to mixed fractions when necessary. These steps will help you handle fractions subtraction confidently and accurately. When we talk about subtracting fractions, it's similar to taking objects away. But remember, the objects must be of the same type. For example, you can only take away apples from a group of apples. It's the same idea with fractions. We can only subtract pieces that are of the same size. That's why the denominators, the bottom numbers, must be the same. If they're different, we need to make them the same before we can subtract. This helps us compare and work with the pieces accurately. So the key point here is that, for subtraction, the fractions need to have the same denominator, ensuring we're subtracting like parts. This concept connects to the overall theme of understanding how to work with parts of a whole in different ways. All right, now let's look at subtracting fractions with the same denominators. The key thing to remember here is that when the denominators are the same, we keep that denominator exactly as it is. Our main focus is on the numerators. To subtract, we simply subtract the top numbers, the numerators, and leave the bottom number, the denominator, unchanged. This makes the process straightforward because the common denominator provides a consistent basis for the subtraction. So always focus on subtracting the numerators, and the denominator stays the same. This method helps simplify the process when working with fractions that share the same denominator, keeping our calculations clear and easy to follow. When subtracting fractions with different denominators, the key step is to change them into like fractions. This means finding a common denominator so that both fractions have the same bottom number. Once they do, it's much easier to subtract the numerators directly. Remember, changing to like fractions doesn't change the value of the fractions. It just puts them in a form that's easier to work with. This concept is really important because it helps us handle a variety of fractions and makes subtraction more straightforward. Throughout this presentation, we're building a toolkit for working with fractions confidently, and mastering this step is a crucial part of that. Now, let's talk about subtracting mixed fractions. The first step is to convert these mixed numbers into improper fractions. This makes the subtraction process much easier because we're working with a common format. Once you have the improper fractions, the next step is to make the denominators the same, turning them into like fractions. This step is crucial because you can only subtract fractions directly when their denominators are equal. After you've aligned the denominators and made the fractions like, you can simply subtract the numerators. Remember, this is the core of the subtraction process. Once you've subtracted, you might end up with an improper fraction, so the final step is to convert that back into a mixed number for the answer, which is often more meaningful and easier to interpret. The key here is to keep the conversions and the common denominators in mind, as they are essential for accurate subtraction. This method of converting, aligning, subtracting, and then converting back helps ensure you handle mixed fractions correctly and confidently. All right, let's talk about multiplying fractions and some key points to remember. First, simplifying is important. Always look for ways to make your fractions easier before multiplying. When it comes to the denominators, remember that they are always multiplied together. So, if you're multiplying two fractions, just multiply the top numbers and the bottom numbers separately. Now, a very common phrase you'll encounter is of. When you see of, it means multiply. For example, if you have 1/2 of 2, that's 1/2 times 2, which equals 1. It's a simple but powerful way to think about parts of a whole or scaled quantities. Next, let's consider the size of the products. If you're multiplying two proper fractions, fractions where the numerator is less than the denominator, their product will always be less than both of the original fractions. Conversely, if you multiply two improper fractions, fractions where the numerator is greater than the denominator, the result will always be larger than either of the original fractions. And if you're mixing an improper fraction with a proper fraction, the product will fall somewhere between the two. Specifically, it will be less than the improper fraction, but greater than the proper one. These points help us understand how the size of the fractions influences the product, which ties into the overall theme of understanding fractions deeply. Keep these concepts in mind as they are fundamental for mastering multiplication of fractions in any context. All right, let's talk about multiplying fractions. When you're multiplying two fractions, the process is quite straightforward. You simply multiply the numerators together and then multiply the denominators together. Think of it as combining the parts of each fraction to find the total. This method works because multiplying fractions essentially combines parts and wholes, so handling the numerators and denominators separately makes the calculation much easier. Remember, this step is fundamental in simplifying more complex fraction problems, and it ties into the overall theme of understanding how parts of a whole interact mathematically. So, keep this process in mind. It's a key tool in your math toolkit for working with fractions. All right, let's talk about multiplying mixed fractions. First, the key step is to change those mixed fractions into improper fractions. This makes the multiplication process much easier because we're working with a single type of fraction. Once you've converted both mixed numbers, you simply multiply the numerators together and the denominators together. Remember, this is the core of multiplying fractions, straightforward multiplication of the top and bottom parts. After you've got your answer as an improper fraction, don't forget to convert it back into a mixed number. This step is important because it helps you understand the size of the product more clearly and keeps your answer in the most familiar form. So, the main points are: convert mixed to improper, multiply, then convert back to a mixed number. This process ties into our overall theme of simplifying complex fraction problems step by step, making them manageable and accurate. Now, let's talk about some important things to know when working with division of fractions. First, simplifying is key. Always look for ways to reduce fractions to their simplest form before multiplying or dividing. Next, multiplication of fractions is straightforward. You multiply the numerators together and the denominators together. But a crucial step before dividing is to change any improper fractions into a mixed number if needed, as it often makes calculations easier. And speaking of fractions, the reciprocal is a really important concept. It's simply the inverse of a fraction. So, for example, the reciprocal of 2/3 is 3/2. Similarly, if you have a mixed number like 1/2, you can convert it to an improper fraction, 5/2, and then find its reciprocal, which would be 2/5. Remember, understanding reciprocals is fundamental because they're used when dividing fractions. Multiplying by the reciprocal essentially flips the fraction around. Connecting this to the overall theme, mastering these concepts helps us handle fractions more confidently and accurately in various real-world situations. All right, let's talk about dividing fractions. When we want to divide one fraction by another, there's a handy trick we can use. Instead of dividing directly, we change our second fraction into its reciprocal. Now, the reciprocal is just flipping the numerator and denominator of that fraction. Once we've done that, we don't divide anymore. Instead, we multiply. We multiply the first fraction by this reciprocal. This method simplifies the process and makes dividing fractions much easier. Remember, the key idea here is that dividing by a fraction is the same as multiplying by its reciprocal. This concept is really important because it helps us handle division of fractions more efficiently, keeping us aligned with our overall goal of mastering fraction operations. All right, let's talk about dividing mixed fractions. The first step is to change those mixed fractions into improper fractions. Remember, this just means converting the whole number and the fraction into a single fraction. Once you have your improper fractions, you multiply them together. This involves multiplying the numerators together and the denominators together. After you get your answer, don't forget to convert it back into a mixed fraction. This step is important because it makes your final answer easier to understand and compare. Overall, the key is to follow these steps carefully to ensure accuracy when dividing mixed fractions. Let's take a closer look at the comparison between greater than and smaller than symbols. These are fundamental when we're comparing fractions or any numbers. Understanding how to interpret these symbols helps us see which value is larger or smaller, which is essential in many mathematical contexts. Now, let's talk about how the denominator controls the fraction. The denominator, the number on the bottom, tells us into how many equal parts the whole is divided. So, a larger denominator means the parts are smaller, and the fraction represents a smaller part of the whole. Conversely, a smaller denominator means larger parts, and thus, a larger fraction. Next, consider how the numerator controls the fraction. The numerator, the top number, indicates how many parts we are considering. A larger numerator means we're taking more parts, which makes the fraction larger, assuming the denominator stays the same. Conversely, a smaller numerator means fewer parts, resulting in a smaller fraction. Connecting these ideas to the overall theme, understanding how the numerator and denominator influence the size of a fraction helps us compare fractions more effectively. It allows us to determine which fractions are greater or smaller, guiding us in making accurate comparisons and decisions in math. Now, let's talk about how to compare fractions using greater than and smaller than concepts. When you're trying to figure out which fraction is bigger, a good starting point is to change the fractions so they have like or common denominators. This makes comparison much easier. Once the fractions are like fractions, the key point is to look at the numerators. The fraction with the larger numerator is the bigger one. So, if you see two fractions with the same denominator, just compare the numerators directly. But what if the numerators are the same? That's when you look at the denominators. The fraction with the smallest denominator is actually the biggest asterisk. This is because a smaller denominator means each part is larger, so the whole fraction is larger. Remember, these rules help us compare fractions quickly and accurately, especially when dealing with different fractions in problems or real-life situations. They tie back to our overall goal of understanding how to work with fractions effectively. So let's talk about how the denominator controls the size of the fraction. The denominator represents the total number of pieces the whole is divided into. Imagine sharing a pizza. If there are two people, each gets half a pizza, which is written as a half. Now, if more people join, say 4, then each person gets a quarter of the pizza, or a quarter. And if even more join, like 8, then each person gets just an eighth of the pizza, or 1/8. What this shows us clearly is that the larger the denominator, the smaller each piece becomes. And if we keep the numerator the same, meaning the part we're talking about doesn't change, the larger the denominator gets, the smaller the fraction becomes. So the key point here is that the denominator controls the size of the pieces, and increasing the denominator makes each piece smaller, which directly affects the value of the fraction. This is a fundamental concept because it helps us understand how fractions work in relation to the whole. Now, let's talk about how the numerator controls the fraction. The numerator, as you know, represents the number of pieces we have. Imagine sharing a pizza with different groups of people. If we share a pizza with 16 people, each person gets 1 out of 16 slices, so the fraction is 1/16. But if we share that same pizza with only 13 people, the slices are a bit larger. We get 3/16 of the pizza. And if we share with just 5 people, each person gets 5/16 of the pizza. The key point here is that when the numerator gets larger, we're essentially dividing the pizza into more pieces or giving out bigger pieces. And if the denominator stays the same, meaning the total number of slices remains fixed, then increasing the numerator makes the fraction bigger. This shows how the numerator directly influences the size of the fraction, especially when the denominator doesn't change. It's a simple yet powerful way to understand how fractions work and how the numerator controls the amount or the part of the whole we're talking about.